I am Kai, and I'm a game developer. I've been programming for like 30 years, no more than that, since I was like 6 years old. Programming in Delphi Pascal for like 30 years. I did graphics, 3D graphics, sound, keyboard input, mouse input, encryption, compression, networking, everything. Like everything. I could do everything in Delphi 2. Unfortunately, Delphi 2 is a 32-bit programming language, only works for Windows, and I can't compile on that anymore. Lost that computer, lost my data like 3 times. I did loads. Then I moved on to C++, and a Raspberry Pi. That was pretty cool. So I've been doing C a little while. I don't know that much about it. I'm learning bits and pieces as I need them. I also learned JavaScript, HTML, JavaScript, and PHP. So I can actually, all of the pretty stuff that I did do on games, I can make in websites. So that's pretty cool. And I was very good at coding, and I thought, well, now try to make it all look pretty, make it all nice. But anyway, this now is the next episode. I am doing, developing a tank game, and showing everyone how to put it together, my process, how I put it together. At the moment, I'm just doing basic, just like to the first milestone, just to show everyone. It's not, you can put anything you want in it. Upgrades, pickups, cheats, anything you want. It's like not limited, but this is just because so that people can follow along. It's so people can follow along with it. For people that are just starting. So I'm showing how I do it. This is not the only way of doing it. People might go, not recommended to do your own engine. Go, but I'm showing you how I make an engine. This is how I do it. You do have problems making your own because you're limited. When you're making your own, you have to worry about speed, timing. Games have to be fast. You've probably only got access to the one processor. If you use threads, you have to do your own threading to use the other processors, which is a pain. Engines probably have this built in already. Hardware accelerated graphics is not easy, but I'm going to show you how. Alright, we've now got to a point where we have now basically, we have got our tanks and stuff CPP main file. So we've gone in here, created a project folder, which should be blank, ideally, with as little as possible in it. Created your game folder, go in the game folder, create the main program, the CPP file here, main, startup, middle, cleanup. Startup returns a ball. The easiest way to test is go, if negative, then do the cleanup and return 1. 1 is, if it has an int output on C, you have to return, otherwise it errors, I think. 0 is no error. I'm just using a 1 as an error. Now I've changed it a little bit, but not much. I've got a section for global constants, a section for global structures, a section for variables. These can be in separate files in a bit, because I already knew this was going to be quite a biggish project. So at the start, this will be in its own file. At the moment, it just prints, running, do the graphics start, it's got nothing in it. Load textures, cell map player, return true. At the moment, this is the startup section. Middle section does the processing and render, and it will do this in a loop. Cleanup will clean up the graphics. This is how far we got so far. Next will be processing. Gets the user input, processes tanks, projectiles, explosions, particles, mines, turrets, collision detection. I've just laid it all out as a skeleton because it's easier to create a skeleton and then fill in the skeleton. Rendering looks like this. Clear tanks, clear the screen, draw the map, draw the players, projectiles, explosions, particles, mines, turrets, and then flip it all to the screen. This is what we've got right now. Next will be, this is my graphics library. At the top here include, I've had to use this path guy. In my home folder it's called project/library/library.h. Library.h, all that does is loads in graphics2d.h. You have to do an include. You use the double dash apostrophes to bring in your own files. That brings in this one. This is the wherever it says include, it just takes all that text from that file and dumps it into this location. That's all it does. And now you're given the headers for all of the files in here, for all the routines you want to make. This is just the headers, blank headers, and this is the body code part. So I'll go over to the body code part. At the moment the body code part is all empty, so now we're going to fill this in. Now we do STL. Luckily I already have a program here that does the STL. We're going to need STL2 include to make this work. That's this. I might put that in the graphics header section. Includes can only be done once. I think it's good to use an if-def to stop it loading twice. I have to find out to do that. Go back here. I will be needing these: a window variable, a renderer, and a texture. So I'm going to create these. These are pointers to one. So I'll put these in my graphics header, graphics library header, like that. Now we're going to create a window, create a renderer, and create and load a texture. This is one texture. This is not ideal being here, but this will do for now. Now the startup, first thing you do is you do an STL init, like this one. This is going to have to return a ball to say if it is worked or not. In here also return a ball. All files must be saved before they are used, otherwise it won't work. Save it. In here, as far as I can tell, as soon as it hits a return, it will immediately stop the processing. I don't know C 100%, but I think as soon as it hits a return, it stops processing. I like using printfs because I like it the C way, and I think you have to go hash, might be S. Here, printf draws whatever is in this, whatever is in between the quote marks, double quote marks to double quote marks. A $S inserts a string at this position and you put the string here. This STL error returns a string. Let's cut that, put that there. Nearly up. Now we try STL init. This is init in video. We can maybe make this init everything possibly, but at the moment it's init just video. If it is not naught, then it errors and returns, and if not, it continues. And if it works, it does the rest of the code here. I just use a // dot just to mean // is a comment, and I use the dot just to say more code is needed here. Right, save that. So that's how we do the init start. And at the bottom of the code we'll have an STL quit. Copy that. So the cleanup just as an STL quit. That's it. Save it. Right, after every time you change anything, always compile. I'm using Windows 11 on WSL layout. There's two things you can do. One, just go here. You've got to install WSL. I think you can only do it on higher Windows level or versions, or use Linux. It will work what I'm doing here. I just click the Ubuntu one. I've installed WSL. So you've got to go away and find out how to do that. Or on Windows you can use WinMG. Not quite sure how to use it. Now what I've done, there's two ways to run this. One way is like this. I'd have to execute this command cd project / tanks and stuff to move from root to the folder. Run the second command, G++, which it compiles for C++. If it's GCC, it will compile for C. If it's G++, it will compile for C++. G++ also compiles lots of different languages. It doesn't only compile C. But you do it like this. The file name.cpp -o for optimize, and then the file name you want to output to. This will work fine for the minute, and then .tanks and stuff to run it. I've done a neat little trick which I will show you, the thing I couldn't get working last time. Now if I go back into my root, Ubuntu root, so I'm in Kai, the root folder, and I made a tanks and stuff shell script here. This is the other way of running it. #bang bin/bash tells it it's a bash script, and these are all bash commands put into one folder, so all of that's run at once. And the file is called tanks and stuff sh shell script, which is here. Now the second way of running it is like this. /. Usually you have to go change mod, create your shell script file, change mod +x. Everything's got to be spelt right. File, tanks and stuff, shell script, change it to executable. Worked. I don't have to do it because I've already done it already. Now, if you go // which means run in Unix, and the file name .shell script, it should work. I got an error. Last time I got an error. There. See, it's run it. It's tried to do the compile. It's found an error on graphics startup. Reference to STL init is not found. That's because it's not linked. So it worked, but I think it has to have -l STL2 like this. This has to be in it to make it work. -l is link, and then what you want it to link. This was not easy to figure out at the beginning, so change it there, save that, go in my shell script, change it in my shell script, save it. Now go back to the command prompt. This is Ubuntu command prompt. Run the shell script again. Cannot find a file, tanks and stuff. If this doesn't work, okay, I will do it manually. The whole one doesn't work properly. Copy the CD that changes the folder. Shift Control V to put it in here. Enter. Done. Use the G compile line command. Copy. Paste that in. Cannot find tanks and stuff. It should be able to. Projects, tanks and stuff CPP. It should work. No such file or directory. Okay, don't know why this is not working. I'll Control C to copy that, so I'll just go ChatGPT. I don't use this for making everything, I use this only for helping me. So there's several ways of finding out how to do something. Go on the internet, web browser, search for it, how to do graphics in JavaScript, for example. You can go to YouTube and go how to do graphics in JavaScript, JavaScript tutorials, for example, or you can go ChatGPT, ask ChatGPT, and ChatGPT will see it, because we learn by seeing the code. When you see the code, you learn by seeing how someone else did it. I'll just go ChatGPT, this doesn't work. I'm on Windows 11, using WSL. The code uses C++ and SDL2. Please can you fix it? I can help, but I need to see the actual code and error you're getting. Paste C source file you aren't working or equivalent section. The exact compiler build command you're using. I haven't inserted the build command. Here's the build command. Give it a build command. ChatGPT is very intelligent, it remembers what you put in last time. You wrote dash elephant must be followed by the output file name. Is being interpreted where the output file name should be. Okay. So dash O must be the last thing according to this. So we make this the last thing, and it worked. If there's no error, it worked. I will change my shell script, file, fix that as well. Dash O, save that. Now I can actually go up till I've got tanks and stuff. Wait a minute. Tanks and stuff with no shell script run worked. That because it drew. Now I've corrected it. Now shell script should work. Enter. No such file or directory. That's because we're not in the root. So I'll close it. I'll go back to reload Ubuntu. We're now in the root of Ubuntu. From the root, this file's in the root, run the shell script, enter. Worked. Literally, it changed the folder. Well, it doesn't look like it's changed the folder, but I suppose it must have done. Compiled it and run it. The problem is, you can get a compile error in the middle and it will give you the compile error here. But it worked. But here, all we've got is SDL start. We've not done anything yet. Here's the next bit. So it creates SDL and it closes SDL. Second part is create a window. Copy, create window. It just so happens that I happen to have an example that does the SDL already, so I already know. I've got this maybe from ChatGPT, I don't know. This one I did from before, I didn't. And now this second part creates the window. In here is whatever text you want for your window title. So I'll call this tanks and stuff. Give it the width. This is the position of the window. Width and height. X and Y. window position. Next will be width and height of the window. I actually want 1024 by 768. This method just creates one window of a fixed width and height, and that's it. Just neaten this up a bit. I know it takes time, but this is what it is. Doing a notepad. Make this into a printf. -S. Up here, I've got to make sure that this is a \n or a /n, because that gives a new line. If you don't have it, it adds stuff to the end. We don't want that. Normal /n, comma. And in this bit, you have to put your STL error, which is a string. It's a char style. Close it. Semicolon at the end here. Semicolon at the end here. Semicolon at the end here. A block, curly bracket open, curly bracket closed, does not have a semicolon. Now we save that. Maybe, I think I might do a closed window at the end. So copy the destroy window here. Put this into the cleanup. I'm using tabs. That's just how I'm doing it. So it destroys the window here, and it's what I'm going to do in here. I will make this G window, the variables. These are global variables from my graphic library that I'm bringing in. They're accessible from everywhere in the program, but I label them as a G to show that they're global. And now in my code, start doesn't have it. This one, this is now a G window. If G window is false, then do this bit, and it would usually be something like if not G window, then I'll do the destroy, otherwise I won't do the destroy. I don't think it matters. I think it will only do it if it's null anyway. There's a reason why I have this, it checks for null. Because here you can check for null. If not null, then free it, otherwise don't free it. If let's just do that anyway. Window. If it is not null, but only if it's not null. So if it's been created, it destroys it, and if it hasn't, it doesn't. So save that. Save everything. Run the script. In cleanup, it's got problem. It's G window. Save that. Try again. Run it again. It's here. The destroy window is not a window, it's a G window. So I'll change that. Here, it's a G window. Save it. Run it again. Run it again. Running. Don't know why it hasn't given you a window yet. I think I know why. So it worked. Create the renderer. I know it all seems slow and difficult, but it's all worth it in the end. Next, we now the startup. Now we add the add renderer part, and I'm keeping my convention as G renderer, G window. And use accelerated. I just think you just generally have to use this. If not, G renderer, because that's what we called it. I just like to use printfs from the old style. I don't think it makes any difference. Slash and you can use standard out, but I just like it this way. And now it creates a renderer. You're creating a renderer, which you have to give it the window. Create a window. Give it the window to the create renderer. It'll create renderer, and it will give you G renderer. And then if G renderer is false, then renderer is error. Return an error and stop. Now go and find the cleanup part. Get rid of the renderer. If G renderer is no, wait a minute. If its G renderer is true, and if window is true, then destroy them. Otherwise, don't destroy them. And make sure you've rendered. It's actually the renderer here, not G renderer. Done that. Saved it. Try running that. Shell script. G renderer. Okay. Little error again. In the cleanup, which is in my graphics library file, and it is this one. G renderer. Save it. Shell script. Done it. Ah, but look. Creates a window, window disappears. This is because middle, this has to go. I'll create a variable called ball L local running. And local running starts as true. We're now in the main loop. This is now to make the next part work. It has to have a loop. While L running. Oh, it's an L. Oh, wait a minute. I might need a G running. It might have to be global because it has to be accessed from somewhere else. So I'll put the running variable up here for now. You could make it a local and pass it down, but I'm just going to put it up here for now. And when the program starts, it becomes a true automatically. Back to the processing. While processing, running is true. Keeps its G running. While G running is true, it'll process, render, and then loop again. Save that. That it will infinitely loop, but I think it's alright. Run it again. Again, now it's in an infinite loop and it will never stop. Don't know how you get out. Maybe Control X, Control V, Z, Control C, Control V. No, I don't know. There might be a keyboard command to get out of this. There it is. You click the X. aha, the X doesn't work. If there is no way out of this, close the terminal window, and that closes all windows. Now, you literally have, go in here, open Ubuntu, go up, execute tensor shell script, it will move folder, compile it and run it, enter, instantly runs it. And there we go. We've now got a graphic window. Now we can do something with it. And we've got the nice title. There's the stuff. Title. Right. Right, there we go. We've got the next major step. It doesn't look like we've done a lot, but we've done the basic program, the basic skeleton structure of it. It's like growing roots underground. You don't see nothing at the beginning. It's not, you don't see all the pretty yet, but it's like roots growing underground. We've done quite a bit. We've now got the graphic window. We've now got graphics in it, and in here it brings in stl2/stl2h. This brings it in, and in here we've initialized stl only with the video, create a window, create the renderer. At the end, destroy the renderer, the window, and quit. I've done it in backward order to what we created them. And in the middle, start, middle and end, middle is a loop which keeps doing process and render. And there we are. We've now got graphic window running. Doesn't look like a lot, but this is a big milestone. Aha, I had to get rid of the little, it appears as a Ubuntu penguin over here. I had to get rid of that before I could do anything. Right, Ubuntu shell script run. For some reason it's not giving me this. I know it will work when I do the flip. When I add the rendering instructions and the flip, I know it will work. I will go in here. I'll go renderer. I'll copy renderer clear. I'm grabbing set draw color renderer clear. So I'm going to add a bit more and do a bit more of it. So I'm just going to add the rendering clear. I'm going to put this one in, put a little bit of rendering because this has to. I have to do this to make this part work. Set draw color. It's got to be the actual renderer variable you're using. And you give it a red, green, this is to clear the screen, red, green and blue value. It's making it black in this instance. We could maybe make the background half blue, just to show that it worked. Renderer. So this you use render clear, STL render clear to clear the whole texture, the background. Set render draw color, use this, will change what this does. The next part I think I need to make it work is I need the render present, because I think without this the window doesn't appear. Go into the render flip. This flips the, when you draw from the back screen, we've drawn on a back screen. When you do a flip, it draws it to the, moves the back screen onto the front screen so you can see it. I think it needs this, otherwise it doesn't work. So I save that, and now I will try running again. Actually, you've got to go file, save all, because otherwise you'll have problems. Recompile and run. Running. It's given me a thing. It's going, for some reason it's not showing it. I've got to go away and figure out why this is not working now. It should work. It's giving me this, not giving me a window. It should be giving me a window. Right, I've got to go away and figure out why this is not working.